Hi everyone, in today's video we're going to talk about the graphs of cosecant and secant. First we'll start with cosecant. So we know that cosecant is equal to 1 over sine, or the reciprocal of sine. So first thing that we're going to do actually is we're going to graph sine, and we're going to use that to help us. So first we need the 4 tick marks that you would use on the unit circle. We need 90 degrees, which is pi over 2. We need 180, which is pi. 270, which is 3 pi over 2, and 360. And then we know that sine will go up to 1 and negative 1. And we know that sine starts at the midline, and it goes up, down, down, up. And what I'm going to do now is I'm going to connect this with a dotted line because we're using this to help us. It's not actually part of the graph. We're actually going to erase it at the end so that I can show you how it's actually not part of the graph. All right, so the first thing we need to do when graphing cosecant is to understand when sine is 0. So if sine is 0, cosecant would be undefined because that would be 1 over 0. So we need to look for where sine is 0 and draw an asymptote. That is what we would represent as an undefined value. So sine is 0 here, so we're going to have an asymptote. Sine is 0 at pi. So we'll have an asymptote there. And sine is 0 at 2 pi. So that's where our asymptotes will be. And now the graph of cosecant is actually really easy. From this maximum here, you're going to draw a parabola shape towards both of the asymptotes. Same thing here at this minimum. We're going to draw a sad parabola towards the asymptotes. And that's it. That is the graph of cosecant. Now, technically, you need to make sure that you are erasing sine because we just used that to help us, right? But this is not part of the graph. So this blue piece that I've graphed here is the answer to the question, right? This is the graph of cosecant. So that sine part just helped me. Excellent. So let's see if we can answer the questions now. So they want us to answer the domain and the range. So the domain, remember, is how wide the graph is. So we see that the graph is contained within these asymptotes. So from 0 to pi and then pi to 2 pi is kind of when we see graphs. So we would see another graph from 2 pi to 3 pi and then even going negative from 0 to negative pi. So how can we write that? So we say that the domain is all real numbers except any multiples of pi. And the real symbolic way to write this, you could say the domain is the set of all x values such that we have all real numbers except any multiples of pi would be k pi, where k is an integer. That is the fancy way to write down what we said here in blue. Okay, range. Range is how tall the graph is. So we see that the range starts here at 1 and goes up to infinity. But then there's no graph in between 1 and negative 1. That's okay, that's not part of the range. But then we have from negative 1 down. So we can write the range in 2 parts. We can say that the range is from 1 to infinity. We need a hard bracket around the 1 because it's an included point in the graph, just as negative 1 is. So we'll say union from negative infinity to negative 1. Always remember the smaller number first, then the bigger number. So that's how we would write the range. All right, let's take a look at secant. So we know that secant is the reciprocal of cos. So secant is 1 over cos. So similarly, what we did before, we're going to graph cosine to help us. So cosine, we need those 4 tick marks from the unit circle. Pi over 2 is 90. Pi is 180. 3 pi over 2 is 270. And 360 is 2 pi. We know cos goes from negative 1 to 1. And we're going to graph cosine. Starts at the maximum and goes down, down, up, up. And again, similarly like we did before, we're going to connect this with a dotted line because it's technically not part of the graph. And again, the way that we start this is we look for where cosine is 0. Why? Because 1 over 0 will give us undefined values, or asymptotes. So it looks like cosine is 0 at pi over 2, and cosine is 0 at 3 pi over 2. And just like we did before, here's the minimum. You can draw a parabola towards the asymptotes. The middle piece is the easiest. Now, here at 0, I don't have another asymptote on this side, so you're only going to graph half of a parabola-looking shape. So you'll just go towards the asymptote. Same thing on this side at 2 pi. Just draw half of a parabola going towards the asymptote. All right, so the domain for this one is a little bit harder to write. So I'm actually just going to write it out first and then explain it. So the domain here, we would say, is all real numbers. This is the symbol that we can use for all real numbers. And we can say all real numbers except 2k plus 1 times pi over 2, where k is an integer. Now let's explain that. The reason why we have to write it this way, let's just say k is 0. 2 times 0 is 0, plus 1 would give me 1 times pi over 2, which is my first undefined. Now let's just say k is 1. 2 times 1 is 2, plus 1 is 3. 3 times pi over 2 is 3 pi over 2. So that's the reason why you need this 2k plus 1, because it's not just every multiple of a half, because a half and then pi is also a multiple of a half. So we have to figure out a way to skip over pi to go to 3 pi over 2. And the way that we do that is by doing 2k plus 1. It basically gives you all of the odd values. 2k plus 1 is really any odd number. So 1 pi over 2, 3 pi over 2, the next one would be 5 pi over 2, and so on and so on. All right, range is very similar to cosecant, where we start at 1 and we go up, and -1 and go down. It's actually identical. So we can say the range is from 1 to infinity and from -infinity to 1. And that's it. Now, I know the domain here in this piece was a little bit challenging, so that's okay. I can definitely go over that a little bit more in class tomorrow. But that's it for today. If you have any questions, now is a good time to jot them down, and I'll see you in class tomorrow. Have a good night.